quadratic equations. Before we jump into quadratic equations, we'll need to first review factoring. These are the steps that I teach my beginning algebra students on how to factor. Step number 1, we always want to make sure the polynomial is written in standard form. Step number 2, we need to check to see if we have any greatest common factors. If we do, factor them out. Also making sure that the leading term is positive at this point. We always begin with these first two steps. After that, we basically count the number of terms, see what type of polynomial we're working with. If there are two terms or a binomial, we want to see if we can factor using one of these three methods: difference of squares, difference of cubes, or sum of cubes. These are the only three methods for factoring binomials. If one of these methods doesn't work, it cannot be factored. And by far the most common method is the difference of squares. Difference of squares, you have two perfect squares that are being subtracted. For instance, a squared minus b squared. This rule tells us we're automatically going to factor this into the factors a plus b times a minus b. The difference of cubes, same general idea, two perfect cubes that are being subtracted. The formula for the difference of cubes is a binomial times a trinomial. The binomial a minus b times the trinomial a squared plus ab plus b squared. And likewise, sum of cubes, two perfect cubes that are being added together, it's going to factor into a plus b times a squared minus ab plus b squared. Notice there's no such rule as a sum of squares. If you have two perfect squares but they're being added, it cannot be factored. The most common type of polynomials we factor are trinomials, polynomials with three terms. And there's a couple methods to go about factoring trinomials. You could simply use a trial and error method, which by the name could take a little bit of time, but with a lot of practice it could save you some time, also be one of the quicker methods. But for most students, we're going to, at least for the more difficult trinomials, convert it into a polynomial with four terms, allowing us to use the grouping method, as I'll show you here in a little while. Once you've factored everything, make sure you always check your factors to see if you can factor any further first of all, and then check your answer by foiling or multiplying the polynomials back together to make sure it does check out that you actually did factor it correctly. So let's look at a few examples. Example 1, y squared minus 64. Notice there's no equal sign. We're simply asked to factor. So step number 1, make sure it's in standard form. It is. Step number 2, check for a greatest common factor, making sure the leading term is positive. It is as well. So now count the number of terms, two terms. Y squared, 64 are both perfect squares. The square root of y squared is y. The square root of 64 is 8. And they're being subtracted, so we're going to factor this using the difference of squares. It's going to factor into y plus 8 and y minus 8. At this point, we have two factors, two things being multiplied. And they're still both binomials, so this is where we want to check to see if we could possibly factor any further. And obviously we cannot. Those two terms in both binomials are not perfect cubes or perfect squares at this point. And we can certainly check ourselves by multiplying them back together. FOIL, multiply the first terms, y and y gives us our y squared. The outer and inner terms, negative 8y and positive 8y, cancel each other out. And the last terms, positive 8 and a negative 8, gives us that negative 64. So we know we have it factored correctly. Example 2, x squared plus 9. It's in standard form. There's no greatest common factor. Once again, a binomial where both terms are perfect squares. However, even both terms are perfect squares, the fact that those terms are being added means we cannot factor it at all. Once again, there's no such rule as the sum of squares. So just because it's an addition sign, it means it's prime. It cannot be factored whatsoever. Example 3, 4x squared plus 21 plus 20x. The first thing we want to do is rewrite this in standard form, which is going to give us 4x squared plus 20x plus 21. Now that it's in standard form, we want to check for a greatest common factor, which we do not have one in this case. So the type of polynomial, once again, a trinomial, three terms. So when we see a trinomial, what we want to do is we want to look for the leading coefficient a, determine if it's equal to 1 or see if it's equal to something other than 1. In this case, a is obviously equal to 4, not equal to 1. A is equal to 4, b is equal to 20, and c is equal to 21. So for this type of polynomial, trinomial where a is not equal to 1, this is where we're going to split up the middle term into two separate terms, giving us a polynomial with a total of 4 terms. The way we do that was we begin by multiplying a times c together. So a times c, 4 times 21 gives us 84, and off to the side of our paper we're going to list the factors of 84. The factors of 1 and 84, 1 and 84, 2 and 42, 3 and 28, 4 and 21, 6 and 14, 7 and 12. And we want to choose the pair of factors that we can either add or subtract together and get that middle term 20. So obviously the only pair that looks like it's going to work is 6 and 14. That tells us how we're going to split up that middle term. We're going to split it up into a 6x and a 14x. And in order to combine those two terms, 6x and 14x, and give a positive 20x, they must be addition. Positive 6x plus 14x. So we're not changing the value of that middle term. We're just breaking it up into two separate terms. Then we're simply going to carry down the first term, carry down the last term, and now we have a polynomial with 4 terms. 4x squared plus 6x plus 14x plus 21. Polynomial of 4 terms, we use the grouping method, which is a little bit more step-by-step approach in how to factor. You group the first 2 terms together in parentheses, the last 2 terms together in parentheses, and factor out the greatest common factor of each. So just from the first set of parentheses, the greatest common factor, 2x, we factor it out, we're left with 2x plus 3. The second set of parentheses, greatest common factor is 7, factored out, we're left with 2x plus 3. At this point, the two sets of parentheses should be the same, and they obviously are. So we're going to factor that common factor, 2x plus 3. And what we're left with from the first term then is a 2x, and from the second term plus 7. So at this point we factored. We have a total of 2 factors at this point, 2 things being multiplied. We want to check to make sure it is completely factored, and they are. We cannot factor either one any further, and we can still certainly check ourselves by foiling. 2x and 2x gives us 4x squared. Outer and inner terms gives us 6x and 14x for a positive 20x, and the last 2 terms 3 and 7 for 21. Example 4. Step number 1, it is in standard form. Step number 2, we do have a greatest common factor. The 3 terms in this polynomial have a few factors in common. We want to factor out the greatest common factor, which is a 9. So we factor it out, we're left with x squared minus 5x minus 6. Still a trinomial, but a lot smaller trinomial, smaller numbers, and now that we factored out the 9, our leading coefficient in the trinomial now is 1, which makes these a lot easier to factor, a lot quicker. We don't have to take the time to split it up into a polynomial with 4 terms. We can factor it outright. We want to choose the pair of factors of constant c that will give us that middle term, 5. Well, 1 and 6 and 2 and 3 both look like it'll work. But in order for the signs to check out, we have to use the 6 and the 1, since the signs in the binomials be 1 positive, 1 negative. So it factors into x minus 6 times x plus 1, which we can still check ourselves. We cannot factor these binomials any further, but we cannot forget to carry down our greatest common factor. The greatest common factor is still a factor, so we need to make sure we carry it down to our final answer. So at this point, we have a total of 3 factors, 3 things being multiplied. Example 5, 5x squared plus 15a. It's in standard form. The greatest common factor, 5a, we factor it out. We're left with x squared plus 3. A binomial still. The first term in the binomial is a perfect square, but the second is not. So we cannot factor that binomial any further, which means we are done at this point. We cannot factor any further. We would not call this problem prime because we have done some factoring. Factoring out the greatest common factor is factoring. It's just all the factoring that we can do. Example 6. It's in standard form. Once again, we do have a greatest common factor we need to factor out, which is 2. Factor it out, and when we do that, we see our binomial now is 2 perfect cubes that are being added, so we're going to factor it further using the sum of cubes. The cube root of x cubed is x, the cube root of 27 is 3. So using the rule of sum of cubes, it's simply going to factor into x plus 3 times x squared minus 3x plus 9, not forgetting to carry down our greatest common factor of 2. Example 7, 8x squared plus 2x minus 21. Already in standard form, no greatest common factor with the leading term already being positive. So obviously a trinomial, but a trinomial where once again a is not equal to 1. So this is the type of problem where we want to split up the middle term into two separate terms, giving us a polynomial with 4 terms. So beginning by multiplying a times c together, 8 times 21, and we don't have to worry about the fact that it's a negative 21. Just multiply 8 times 21, 168. List the factors of 168, 1 and 168, 2 and 84, but keeping in mind that we need two factors that differ by only 2 to give us that middle term b here. So we have a ways to go, so we may want to skip a few. The factors that gave us 168, we multiply the 8 and 21 together, so we're getting closer to two numbers that differ by 2. The two factors that we need, 12 and 14, so we're going to split up that middle term into a 12x and a 14x. In order to combine these two terms and give us a positive 2x, it must be a negative 12x and a positive 14x. Bring down the first term, 8x squared, bring down that last term, minus 21. Now we have a polynomial of 4 terms allowing us to factor using the grouping method. Group the first two terms together in parentheses, the last two. Factor out the greatest common factor from the first set of parentheses, 4x, leaving us 2x minus 3. The next set of parentheses, 7, leaving us again 2x minus 3. So factor that 2x minus 3 out in front. What we're left with then is 4x plus 7. Number 8, it's in standard form. We do have a greatest common factor of 15, so we factor it out. We're left with then x squared plus 3x minus 10. Still a trinomial, but a lot smaller, easier trinomial to factor. Now our trinomial has a leading coefficient of 1, so all we have to do in order to factor it is choose a pair of factors of 10 that we can combine to get that middle term 3, which is obviously going to be 2 and 5. So it's going to factor into x minus 2 times x plus 5, not forgetting to carry down that 15. So a total of 3 factors. So factoring, extremely important. We're going to be using it a lot here. And it's the backbone, for now anyway, for solving quadratic equations. So first of all, the way we recognize a quadratic equation, it's an equation, has an equal sign. But if your variable x has an exponent of 2, it's a quadratic equation. Obviously not linear, it's not going to graph a line, it's going to graph a parabola, which we'll talk about parabolas later on in the course. So the way we solve quadratic equations, we want to begin by getting all the terms on one side of the equation, in other words, setting the equation equal to 0. So example 1, 20x plus x squared is equal to negative 91. So we see the equal sign, it's an equation. Even though the first term has a 20x where x has an exponent of 1, our variable's largest exponent in the equation is 2, so therefore it's a quadratic equation. So I'm going to move that negative 91 over to the left, and in the process of doing that, I'm also going to write the terms in standard form. So x squared plus 20x plus 91 is equal to 0. For the time being, I'm going to forget about that equals 0. All I do is factor the left-hand side using our same factoring steps. Trinomial, a is equal to 1, so it's going to factor into x plus 7 times x plus 13. Two factors, it's completely factored at this point, so now we need to take it a step further and actually solve the equation. What we need to do at this point is we're going to set each factor that has a variable equal to 0. So we have two factors, they both have a variable x, so we're going to set each factor equal to 0. The first factor, x plus 7, gets set equal to 0, gives us the equation x plus 7 is equal to 0. The second equation, x plus 13 is equal to 0. Now all we do is solve each one of these equations. Subtract 7 from both sides, subtract 13 from both sides. Two solutions, negative 7 and negative 13, you have to have them both. Example 2, quadratic equation, equal sign, x's largest exponent is 2. It's already in standard form set equal to 0, so we can jump right into factoring. Don't forget to check for a greatest common factor, which is in this case going to be 2. It leaves us then 2 times x squared minus 14 is equal to 0. Continue factoring, difference of squares, it factors into x minus 4 times x plus 4. So it's completely factored. At this point we have a total of 3 factors But in order to solve the equation, we only set the factors that have a variable equal to 0. So that first factor 2, we're not going to do anything with. X minus 4 obviously has a variable, set it equal to 0. And x plus 4, set it equal to 0 as well. Solve each equation. Gives us two solutions, positive 4 and negative 4. Example 5. Example 3, another quadratic equation. It's already in standard form, set equal to 0, so even though the leading coefficient here, a, is not equal to 1, it's a pretty small number, so you should be able to easily factor it. We know the first terms in each factors has to be x and 3x. We know the last terms have to be 1 and 1. And we know the signs both have to be subtraction. So it factors in the 3x minus 1, x minus 3, set each factor equal to 0 and solve. The first solution, add 1, divide by 3, so x is equal to 1/3. Add 1 for the second equation, x is equal to 1. And example 4, x squared minus 64x is equal to 0, equal sign, x is largest, x1 is 2, so another quadratic equation. Step number 1 is already done, it's already in standard form, set equal to 0. So factor out the greatest common factor, and by doing that, we've already have it completely factored at this point. We have still a binomial inside the set of parentheses, but we can't factor it any further. We have a total of 2 factors, and they both have variables, so we simply set each one equal to 0 and solve. By setting that first factor equal to 0, it already gives us the first solution. X is simply equal to 0. The second one adds 64 to both sides. So 0 and 64.